All right, so far we said a central angle is equal to the measure of its intercepted arc. That's where the vertex is the center. An inscribed angle is equal to 1/2 the measure of its intercepted arc. That's where the vertex is on the circle. But there's another situation where the vertex is on the circle, and that's when a chord and a tangent intersect a circle from a point on a circle. Then, too, is the angle half of the arc. Now we're going to deal with an angle whose vertex is in the circle but not the center, and angles whose vertex is outside the circle. Okay? First, an angle inside but not the center, Theorem 9-7. An angle formed by two chords that intersect in a circle is equal to 1/2 the sum of the intercepted arcs. And remember, there's a chart in Unit 9.3 that summarizes all these rules, okay? So, we have two chords that intersect inside the circle. When they do, you have two pairs of vertical angles. Angle 1 is vertical to this angle. So angle 1 is equal to half the sum of its intercepted arcs. But what arcs are we talking about? We're talking about the arc that angle 1 intercepts and the arc that the angle vertical to it intercepts. So angle 1 is half the sum of the arcs being its arc and its vertical angle's arc. So angle 1 is 1/2 the sum of those. Their sum is 170. Half of 170 is 85. And so angle 1 would be 85 along with the angle vertical to it. Again, we have two chords that intersect inside of a circle. When two chords intersect inside a circle, the angle formed is equal to half the measure of its intercepted arcs. And when we're talking about the intercepted arcs, we're talking about its arc and its vertical angle's arc. So the angle, which is 70 degrees, is half the sum of its arcs, arc AB and 90 degrees. And so we can solve that equation algebraically. Now we could get rid of that half by multiplying by 2. It'll just kind of wipe that out. And multiply this by 2 and get 140 equal AB plus 90. Or you could have distributed that 1/2. Now we're going to undo addition, subtraction. So we're going to subtract 90, and that's arc AB. And we get arc AB is equal to 50 degrees. So an angle formed by two chords in a circle that intersect in a circle is equal to 1/2 the sum of the intercepted arc. And what we talk about is where's the vertex? The vertex is inside, but not the center. Therefore, the angle is half the sum of the arcs. Okay? Theorem 9-8. In this situation, we're creating an angle whose vertex is outside the circle. That could happen by drawing secants to the circle from a point outside. Two tangents to the circle from a point outside, or a secant and a tangent. So we could have two secants, two tangents, or a secant and a tangent. An angle formed by two secants, two tangents, or a secant and a tangent drawn to a circle from a point outside is equal to 1/2 the difference in the intercepted arcs. So in the first example, we have two secants. The intercepted arcs are 100 degrees, 100 degrees and 30 degrees. The names of them were DE and BC. So angle A is half of their difference. So angle A is 1/2 of their difference, which is 100 minus 30. 100 minus 30 is 70. So angle A is half of that. And so angle A is 35 degrees. Okay. Angle A is a figure formed by two tangents to a circle from a point outside. We have to focus here on the points of tangent C. If we go the long way around from one point of tangent C to the other, that's one of our two arcs. If we go the short way from point of tangent C to point of tangent C, that's the other of our two arcs. We know that a circle is 360 degrees. We've got the little black arc is 110. So to find the green arc BDC, we would take what a whole circle is, 360, minus 110, and we would get what the green one is, 250 degrees. Try to scoot that over a little bit. Angle A is 1/2 the difference in the intercepted arcs. The intercepted arcs were BDC. And BC. So angle A is 1/2 their difference. Their measures were 250 and 110. And so angle A is equal to 1/2 that difference. The difference being 140. And so angle A is half of that, which is 70 degrees. Okay? On the third one, A is an angle formed by a secant and a tangent. The vertex is still outside, so it's 1/2 the difference in the intercepted arcs. We have to think about the point of tangent C. From C to the point of tangent C is one of my arcs. From D to my point of tangent C is the other arc. And so angle A is 1/2 of arc CB. And arc BD. So angle A is 1/2 the difference in their measures. Their measures were 140 and 40. So angle A is 1/2 of that difference, 100, half of which is 50. I'm having trouble writing. And so angle A is 50 degrees. 50 degrees. Okay? Any questions on Theorem 9.8? So if the vertex is the center, the angle is equal to the arc. If the vertex is on the circle, the angle is half the arc. If the vertex is on the inside, but not the center, the angle is half the sum. If the angle is on the outside, then the angle is half the difference. Okay? All right. Daily work unit 9.6. Daily work unit 9.6. All right, let's just look at numbers 3 and 4. Number 3, it wants to know angle 1. So we say, where's its vertex? Well, it's on the inside. If it's on the inside, then what's the rule? The rule is that the angle is half the sum of the arcs. What arcs? Angle 1's arc, which is 110, and its vertical angle's arc, which is 40. So angle 1 is 1/2 the sum because it's inside but not the center. The sum of what? Its arc and its vertical angle's arc. And so angle 1 is 1/2 the sum of those, which is 150, half of which is 75 degrees. So angle 1 is 75 degrees. The vertex was on the inside, but not the center, so it's 1/2 the sum of the intercepted arcs. Okay? You get to angle B and we say, well, where's its vertex? On the circle. What's the rule? It's half the arc. How much is the arc? Well, it's the sum of 38 and 40, which is 78. So angle B is half of 78, which is 39 degrees. Where's the vertex? On the circle. What's the rule? It's half the arc. Okay? All right, let's scoot down here to another one. Let's just look at 11 through 14. That looks like a pretty good stretch of problems. We're just going to kind of clean up a little so we can focus on that one picture. Get all the distraction out of the way. Looks like a lot of stuff to think about there. It looks kind of intimidating at times, but if we know all of our rules and we just think through it, it's not really so bad. Angle BAC. Angle BAC, that's from B to A to C. Where's the vertex? The center. What's the rule? It's equal to the arc. The arc is 50, angle's 50. Angle FEB. Where's the vertex? On the circle. What's the rule? Half the arc. Half of 70 is 35. Angle FEB is 35 degrees. Angle BED. B to E to D. Where's the vertex? On the circle. What's the rule? It's half the arc. How much is the arc? Well, it's a semicircle because that's a diameter. A semicircle is 180 degrees. Half of 180 is 90, so angle BED must be 90 degrees. The vertex is on the circle. It's half the arc. The arc it hit was a semicircle. We knew that because BE was a diameter, which would cut the circle in half. Half of 360 is 180. So the arc is 180. The vertex is on the circle. It's half of that, which is 90. Okay? Angle EDC. Where's the vertex? Outside. What's the rule? Half the difference in the intercepted arc. That's an angle formed by two tangents to a circle from a point outside. What arcs? The long way around from the points of tangency and the short way around to the points of tangency. Now, how are we going to get those arcs? Well, we know that BE is a diameter So from B to E is a semicircle, which is 180 degrees. That part's 50 degrees. 180 minus 150 leaves 130 degrees. So the green arc is 130. It and the blue are the whole circle, 360. 360 minus 130 is 230 for the blue angle. So the long way around is 230 degrees. The short way around is 130 degrees. The angle is half the difference because its vertex is outside. The difference is 100 degrees. Half of that is 50 degrees. And so angle D is 50 degrees. Any questions on that? Where's the vertex? What's the rule for that? Okay? Well, we covered some pretty good stuff. I need to leave you plenty to dig on your own. Maybe we should just leave you the rest to practice. We'll just leave it there and let you practice the rest. Don't forget the odd answers you can check.